I get to work for Disney Television Animation. And look, I don't want to brag or anything, but working for Disney automatically makes my Cypress test suite the most magical and happiest tests on earth. Sometimes, occasionally, one of my tests will randomly fail, even though I previously worked before. This is the definition of test flake, when a test returns a different result without consistency, which is exactly what this session is about. First off, though, why do we care about flake at all? Fundamentally, we write automation tests to catch application bugs faster and with increased reliability. Having confidence the test result is accurate is the single most important aspect of a test. If you're not able to trust when your test fails, well, then its fundamental purpose is gone. Test flake is common, and honestly, it's okay. It's very easy to write tests, but it's very hard to write resilient ones. However, being aware of when different types of flake can occur is critical in taking your test suite to the next level. The more variables that you can control and account for means increased test result confidence long term. In this agenda, we'll be discussing the dangers of test flake and ignoring it, as well as breaking down different types of categories of flake with a little bit of some solutions. And then finally, we'll be talking about why flake can actually be good, maybe, and reveal some real application issues. All right, let's begin with a quote from renowned automation expert and Cypress user Michael Scott, of course, the one and only, who I think once said a flaky test is more detrimental than not having the test at all. So, okay, maybe he didn't actually say this. I don't know. It's been a long time since I've watched the show, but this is my personal belief, and let me try and explain why. This is because the side effects of having test flake are numerous, including but not limited to decreases in test confidence, obviously, but also decreases in engineering trust. You don't want to be the engineer who cried wolf to your teammates only to find out that the test was simply unreliable and there wasn't a real problem. Additionally, test flake can result in increases in missed bugs or false negatives, increases in debugging time, long term engineering costs, and personally for me, and probably for others, tear in coffee usage. Flake is extremely frustrating, but that's not all. Don't you wait. Let's take a look at the impact of Flake long term as well. Okay, so let's pretend you start with 10 tests, but only one of them is flaky. So that's only 10% of our entire test suite that's unreliable, right? But it's just one test. So we can ignore it. And then we get to 50 tests, but we still have 10% of our tests, which are flaky, which is now five tests. And we let this pattern continue and continue as we get more and more tests. And what we see with the graph on the right is that as our test suite grows, represented by that x axis, even though the test flake percentage stays the same, the amount of tests that are unreliable doesn't. This means over time, the tech debt involved investigating these tests is going to cost numerous more hours debugging them than if we just attack them early, eventually getting to the point where it's simply unmanageable. Some approaches to this, to resolving this, would just be getting in the habit of attacking Flake early. As soon as you identify Flake, spend the time to remediate it. Don't context switch while it's still fresh on your mind. There's a good chance that whatever introduced a flake is a very recent change. Additionally, if you don't have the time to remediate it then, try and quarantine the tests. So skip them until you have the bandwidth to investigate them later. Just don't leave the false failures laying around in your test results. Also, don't retry on test or don't rely on test retries, right? I was super guilty of this early on in my career, where I would cover up flaky tests by just hoping they'd go away by retrying over and over again. This may seem fine at first, but I was just ignoring real issues, and it's a bad pattern and one you shouldn't rely on. Finally, worst case scenario, if you're not able to fix a test, consider starting from scratch or reconsider the value of it overall. Do you actually need it if it's not going to be useful? Now, let's take a look at some different types of flake. The first being pretty straightforward, but honestly easily overlooked, which is just simply understanding the tool you're using. Think about a real world example like crafting or woodworking. If you dive right into building something without understanding the right tools, can you actually guarantee the result is going to be what you want? So you could use the wrong screwdriver or not measure, or you don't follow the instructions, and you could end up hurting yourself and creating something wildly incorrect than what you envisioned. This same concept applies with writing tests in Cypress. Do you honestly understand the commands you're using? And are you using the right commands to build the test that you need? Cypress has an amazing set of documentation, and by not taking the time to understand how it works and its capabilities, you could actually introduce Flake just by misuse. Let's try and take a look at a couple examples where this could happen. First, imagine you're asked to validate some text in the first game schedule box on NHL.com that's highlighted on the image on the left. So we might write a test like the one on the right, where we simply visit a site, grab all of the game boxes, take the first one, and validate the text. It's pretty straightforward, right? But this test could actually pass sometimes and fail some other times. Why? Well, it's because cy.get isn't always guaranteed to return the entire list of game schedule boxes. In fact, cy.get always returns the first matching selector, which in our case would be the first game box that actually loads. So if our application, for some reason, loaded the third game box before the others or was randomized, we could end up grabbing the wrong box and it would fail. Now, of course, chances are our application won't do this, but making the wrong assumptions about cy.get could lead us to grabbing the wrong element if it ever did. Luckily, we can always safeguard cy.get, which to always guarantee we grab the right element we intend to. A few ways to harden your tests are by simply adding what's called a safeguard validation or assertion. So in the code on the left, by adding an assertion that validates the length of all of our boxes, Cypress is going to internally retry until it's successfully gotten all of them before continuing. This guarantees we always get the total list of elements, regardless of how they load in the page. So when we grab the first box in our list, it's going to be the right one. Alternatively, we can use a better selector, such as a data-test ID attribute, directly onto that component. So each individual game box would have a unique identifier, so it would never matter what order the data loaded. We know that when we call cy.get, we always get the right one, and there's never that variability. Another command that could potentially introduce accidental flake with misuse is cy.intercept. Let's take a look at another example where we visit a site, intercept an endpoint, wait on that endpoint to finish loading all of our data, then validate some text. Again, why would this sometimes pass and sometimes fail? Well, the issue is we didn't understand that we define the intercept at the same time the real API request occurs. So, depending on how Cypress runs and the timing of our application, what could happen is after visiting the site, the real API request could be triggered before we define our intercept. So, by the time we try to wait for it, Cypress won't be able to find it. Sometimes it could pass and sometimes it could fail, just simply on the timing of things. The simple fix for this is to always define your intercept before the request is triggered. In our case, we had the correct command syntax, but our implementation left us open for Flake because we truly didn't understand how it's supposed to work. Another type of common flake and a large pain point for many occurs when a test is run locally and passes, but then you run it in the pipeline and it fails. Let's take a look at some reasons for this and how we might be able to address them. So the biggest difference that I see between local and the pipeline is simply how the application performs. It's probably extremely rare for your local machine to be identical to those running in the pipeline. This could introduce variability in the amount of resources the machine has, how fast it makes and handles API calls, how fast and when the DOM reloads, and finally, different browser version differences. All of these differences can lead to startling results in how quickly your tests execute. So, for example, the graph on this slide represents 5 of my real test specs. In blue, we can see how long they took in seconds when they were run on my local machine, while in green, we can see how long they took when run in the pipeline. For me, every single test runs faster in the pipeline, and honestly, some significantly faster, just due to the differences in the machines that the test ran. With such variability, though, how can we actually help mitigate when there are these differences in how fast things run? One way we can accomplish this is just by waiting before asserting. Let's take a look at the code on the left in which we want to type a user's name into a form, click submit, and then validate the user now exists in some table. But what happens if the pipeline executes faster than the local environment in which the test was written? Could Cypress try and validate the results table before the API call to add the user has completed? Absolutely. This is a timing issue and one that I've run into myself. As explained with CY intercept before, and looking at that top image on the right, we can intercept a request and wait for it. Cypress will pause and wait for our post call to complete before we validate the table. This means that no matter how fast the test is executing, we always know the user data will be in the user table before asserting against it. Additionally, if you want, you can add a one-off timeout on the cy.get command. So in that code on the bottom right, we just add a timeout of 10 seconds, which means cy.get will internally retry up to 10 seconds until it finds the new user in the results table. I don't typically prefer using explicit waits like this since they're still limiting ourselves to some extent. Like, what if the post call takes more than 10 seconds on a bad day? But it's a good trick to know and capitalizes on Cypress's built in retry functionality for a quick solution. Okay, that being said, please don't ever do this. Do not use an explicit wait using cy.wait itself, as this is a huge anti pattern. Doing this guarantees that the test will wait 10 seconds every single time it runs. The two examples before meant Cypress will wait up until the timeout time. This means it will always wait that amount of time. So if your API call takes 5 seconds, but you wait 10 seconds, you're actually padding your test by 5 seconds every single time unnecessarily. It's a small thing, but doing this over and over and over again adds up. Plus, remember, timeouts aren't always guaranteed to work depending on the speed of execution. Another way we can guarantee our tests always pass in the pipeline or locally is to add a safeguard assertion again, similarly to what we described earlier with that cy.get example. By adding an assertion such as should exist, be visible, be enabled, we always guarantee that the element will be in the specific state we want it to before acting upon it. What I mean by this is if I want to click a button, I might assert that it's enabled first before clicking it. Doing this forces Cypress to validate the element is in a clickable state before I actually do it in the test. Similarly, we could validate an element is visible before typing into it, such as the example on this slide. It's a simple pattern and it's easy to and it helps to easily guarantee that before we do an action, regardless of how things execute, we are always in the right state. Finally, one last reason that could cause flake between the local and the pipeline is running tests in parallel. Now, hold your pitchforks because I know what you're thinking. We want to run tests in parallel. It's desired because it leads to overall faster execution speeds. But if you're actually running multiple tests at the same time against the same environment, you could actually run into issues if you're not careful. For example, what if we take our example from before about which was adding a user into a user table? And we have two tests that do that in two different specs. So if we run the tests one after another, of course it's going to work, right? They're not going to conflict. But if you run them in parallel, what happens if those tests run at the same time? What if they update the same underlying data and break each other? Ensuring tests are using their own data, or ideally having each test create and clean up its own data, guarantees you will never run into this type of conflict. Um, One thing that can help debug this type of flake is using Cypress's cloud spec summary as depicted in this slide. So for us, we had two failures, and we can see what tests ran at the same time when they happen to fail. This could help you debug if these failures are new and they didn't happen before parallelization. So another thing to consider is that when you run your tests in parallel, also, can your environments actually handle the additional load and when you run more tests? So can you handle multiple users now? Can your APIs handle the additional stress the more times they're hit in rapid succession? I've actually had a ton of tests fail in the past just by introducing parallelization because my APIs were timing out just due to limitations. Now we went back and fixed the APIs, but it was extremely frustrating and hard to track down. And it's just because I didn't consider the environment itself couldn't handle that amount of stress. The last type of flake we'll discuss is test independence. Essentially, can your tests run on their own and over and over again reliably? So let's take a look at two simple tests. One test visits an application, validates some text, but the second test only does an assertion. Both tests would pass initially if run one after another, but could they work on their own? We can determine if a test is independent using a very simple and known trick. Just add a dot only to that individual test, just like the image on the right, to force it to run. We know that if we did this, of course, that test would fail because we're asserting without having visited the website, right? The second test needed the first one to run. So how do you always guarantee and create independence? Honestly, the quickest thing you can do is to simply upgrade to version 12 of Cypress or above. In these versions, Cypress did a ton of work to natively support test independence just out of the box. They reset all your cookies, storage, paid state from the previous test. So if you upgrade to this version or higher, it actually forces you to write tests independently. Now, another thing you can do is let's take our example again and pretend we also now want to log in before we visit the site. So if we consider our two tests, the only difference between these two tests is the validation between them. We know that logging in and visiting the application is shared setup. So we can use a before each hook to define the shared setup, guaranteeing each test will be able to run without needing the other one. Additionally, and specifically for authentication, we can take advantage of cy.session, like I do in this slide, which will cache and restore cookies in storage between my tests. So that means when I run the second test, cy.session would just restore the session from the previous test, meaning I wouldn't need to relog in through the UI every single time. I would highly recommend looking into this if you're not already. It saves a ton of time with bigger test suites, and it guarantees consistency across tests. Okay, so we've looked at how you can create accidental failures between multiple tests, but what about if you have a test that runs once and then you run it again and it fails? As you write tests, it's also very important to consider retriability. If we take our test case from before about submitting a user into a user table, we type our test or we type our user into the form, click submit, and then we validate the table. The first time it runs, it passes, and we see our user like in that screenshot on the right. However, when we run this again, it actually fails. We didn't check the sad Michael Scott 500 server error. I'm sure we've all gotten that. What could have possibly happened? It's because our post user API call actually prevents us from adding the same user twice, which could be a real API limitation that I'm sure some of you are familiar with and struggle with. Sure, we wrote a test that works once, but we wrote it in a way that doesn't work with our APIs. Simply, we can't retry it. So how do you fix a problem like this? The easiest approach of doing this would just be to reset the state of all before your tests run. So for us, this means deleting the user from the user table. By doing this cleanup in a before each hook, like in our example, we always guarantee that our test is going to be in a clean state before it begins. You'll notice that my delete if user exists custom command also programmatically deletes the user. It doesn't use the UI. This is not only faster, but it ensures it's not dependent on certain parts of the UI working when the test doesn't care about it. If I'm testing user creation, I don't need to be validating how a user is going to delete. That should be another test, right? Finally, in this example, I could also just rely on random data. So I could type a random string as my user every single time, but depending on how that data is generated, like through a faker library, collisions can still happen. So you need to be careful. Additionally, I could generate bad random data. What if my user inputs only accept words, but my random library sometimes generates numbers? Sometimes my test might just fail because I gave it bad data accidentally. All of these things can be used together, but you should be careful and you truly need to understand how your application works to find the right way to reset your test before running it. Okay, so we've discussed a lot about how different flake can happen and be remediated, but what if the flake itself was good? A sentence I don't think anyone's ever said before. What if there's a reason not to patch the test to address the flake, but what if we actually want to fix a real application issue? Let's take a look. So let's take our user table example again, but now we actually want to delete a user. We write a simple test that navigates to our application. We click the delete button, we wait on the delete, and then we validate the user's gone. Now, what happens is sometimes this test has flake. Sometimes our button is responsive, and sometimes that click is working, and sometimes it isn't. This is because Cypress is occasionally clicking the button before the page fully loads, meaning the click is trying to delete nothing, which is causing an API issue. So this problem might sound familiar, right, to some of the timing stuff we discussed earlier. So we could patch this test pretty easily by adding a CY intercept to wait for all our data to load before we click it. However, what this flake demonstrates is that if Cypress can create this bad behavior, maybe a real user could too. Maybe they could actually click that delete button before it's ready to actually be clicked. And maybe we shouldn't patch the test, but actually fix the application. So as a solution, maybe we ensure our button component has a disabled attribute with some logic so it's not actually enabled until the page itself is fully rendered. Just because we have all these amazing ways to harden our tests doesn't mean we should. Next time you're debugging, channel your inner flake whisperer before jumping to conclusions that it's always the test's fault. Sometimes we might want to blame it on the application instead, right? Okay, so finally, the last thing to discuss is that flake happens. Maybe there's a network down, or the environment crashes, or there's just randomness that we can't control. It's okay. A lot of these really random edge failures can be ignored by allowing retries in the pipeline. That's what they're there for. Test retries should be enabled to help the rarest of randomness when running our tests. However, allowing test retries to cover up the common failures we've discussed, or potentially real failures, is dangerous. And once again, it undermines the entire confidence of our tests. This is something I stressed really early on. So if you do enable test retries, it's always good to get into the habits of monitoring your flake to see how common they are and when they've occurred. Some ways you can do this if you have Cypress Cloud are using their Flake analytics reporting, which is shown in the image on the top. This easily shows you the overall state of your flake, including which tests are having the most flake, so you can resolve the biggest offenders. Additionally, Cypress just released Branch Review, which integrates with GitHub and can easily tell you the impact of pull requests, making it easier than ever to identify new code flake fast, which is shown on the image below. Also, it sounded like in the roadmap earlier, there's an upcoming burn-in feature. So I'm really excited about that because Cypress is, again, elevating flake detection. So look out for that. There's a lot of exciting tools that are baked in to help us crush test flake. Okay, as a recap, I could spend 30 minutes on each slide if I had the time. There's so much to discuss with Flake, but hopefully this gives you a good idea on how to think about it and handle some common types. Remember, if there's one thing to take away, confidence is everything. You simply have to trust your tests. That's what they're there for. Flake is frustrating, but by taking a step back and breaking it down instead of randomly guessing or covering it up will save you time in the long run, and you'll actually fix a real issue, which kind of feels good, right? Just be patient, but make sure to move fast. Don't spin your tires and get stuck because ultimately you're not alone. There's so many informative resources online, including the Cypress Discord. So if you've run into a problem, chances are someone else has too. Okay, thank you so much. Get out there. Please be the world's best tester, just like Michael Scott is, of course. And thank you so much for your time.